This is our midterm project. It's a 4-cylinder steam engine. It's created by myself, Chris Kirchhoff, and Jonathan McNellis. The assignment overview is pretty much each team member was assigned parts, as you can see in Table 1. And out of those parts, 2 of them had to have dimension drawings, and they are designated by the asterisk. The team, we worked together to create assembled and exploded view B-size drawings, and also 3 and 4 view drawings for each individual part. Along with that, we defined which workbenches and tools were used to make each part. The assembled and exploded view are seen here. The left is the assembled and right is exploded. The parts list indicates the part number, part name, quantity, and material. Brass, stainless steel, and copper, along with aluminum pistons, were the main materials of all the components. Here you see the assembled product. It's an assembly that is made up of 6 different sub-assemblies that we'll get into in the next slides. Assembly 103 consists of a cylinder, cylinder fastener, cylinder top, horizontal beam, and standard hardware. Here you can see the horizontal beam made in the part design workbench that utilized the pad, pocket, hole, and rectangular pattern tools. The cylinder fastener made in part design workbench used pad and hole tools. The cylinder top made in part design was created using the shaft and hole tools, and the cylinder was made in part design as well, which utilized pad and hole tools.
Moving on to assembly number 104, you can see this is very similar to Chris's part, assembly number 103. It contains the following parts: the cylinder fastener 2, the cylinder top, the vertical beam, and standard hardware. The vertical beam was created using a pad, pocket, and hole. The cylinder fastener 2 was created using a pad and a hole. Cylinder top was created using a shaft and a hole, and the cylinder was created using a pad and a hole. Moving on to assembly number 105, this contains the following: the subassembly 103 and subassembly 104, which we showed earlier, the crankshaft bearing, 2 of the inlet pipe number 1, 2 of the inlet pipe number 2, and standard hardware. The inlet pipe 1 was created using a rib, the inlet pipe 2 was created using a rib, the crankshaft bearing was created using a pad, pocket, hole, and circular pattern, as well as the subassemblies 103 and 104.
Here you see assembly 200. Assembly 200 consists of a subassembly 105 that we went over before, base plate, fresh steam inlet pipe, reversing valve housing, reversing valve knob, reversing valve, 2 exhaust pipes, spindle bracket, and various standard hardware. Broken apart here, we see that the reversing valve made in part design utilized shaft and hole tools. Subassembly 105 is one that was covered before. Base plate was created in part design utilizing pad, hole, rectangular pattern, and chamfer tools. The fresh steam inlet pipe made in part design utilized just the pad and hole tools. Continuing on, the spindle bracket, also made in part design, utilized pad, hole, and rectangular pattern tools. The exhaust pipe was created just using the rib tool in part design. Reversing valve housing was created using pad, hole, and rectangular pattern tools, while the reversing valve knob was created in part design using pad, chamfer, and hole tools.
Assembly 101 consists of the crosshead, the piston rod, and the piston. The piston was created using a pad and a hole, The crosshead was created using a pad and a hole, and the piston rod was created using pad, pocket, and thread. Assembly 102 consists of a flywheel, a crankshaft, the crank plate, the roller bearing screw, as well as standard hardware. The crankshaft was created using a shaft, pocket, hole, and mirror. The crank plate was created using a pad, pocket, and hole. The roller bearing screw was created using a pad, pocket, chamfer, and thread, and the flywheel was created using a pad, pocket, hole, and circular pattern. Moving on to the final assembly, you can see this involves assembly number 200, assembly number 102, and 2 of the assembly number 101s. Assembly number 102 with the flywheel and the crankshaft goes through the crankshaft bearing of assembly number 200. Both assembly number 101's pistons go into the cylinders. The crossheads of the assembly number 101's contact the roller bearing screw, and as the pistons are forced in and out, make the roller bearing screw turn, which then makes the flywheel turn as it is attached via the crankshaft.
During the project, we had some difficulties. The horizontal beam out of my parts was probably the most difficult one to make drawings for, because the drawing itself would not fit into one drawing. So we had to create 2 different sheets, sheet 1 and sheet 2, which you can see here, that was able to dimension the horizontal beam. Also, the callouts for threaded holes weren't necessarily covered in class, but we were able to find the information to be able to call those holes out correctly.
I also had some difficulties with my crankshaft. This was somewhat of a complex shaft that you had to revolve around a central axis, and also some of the holes going through the front face, only part of the hole is threaded and the rest is not threaded. So you had to make sure using the hole command that you only threaded it a certain depth, and then the rest of the depth of the hole was not threaded. In conclusion, the project was accomplished efficiently and in a timely manner. The work was evenly distributed between both team members, each of us having about the same number of parts, as well as difficulty level of the parts was on par with each other. Improvements could be made with the individual part orientation as well as the exploded view drawing. The exploded view drawing was a little bit crowded. There was a lot of parts to put on that drawing, and it seemed a little cluttered at the end. Overall, this project was a success. We hope that you enjoyed watching the video, and thank you.